Welcome to the chapter Motion.
This slide presents the overview of the chapter. Learning objectives. By the end of this chapter, you will be able to
Understand the concept of relative motion. Differentiate the distance and displacement. Draw the displacement vectors. Define the average velocity and average speed. Discuss about the uniform and non-uniform motion. Explain the term acceleration. Derive the equations of uniform accelerated motion.
Introduction.
What is relative? We use many statements in our daily life to express our views. The meaning of a statement depends on the relation between the words used in it. For example, observe the statements on the screen. The words have a perfect individual meaning. Both the statements are constructed using the above words. But the statement 1 has a no proper meaning or sense, and the statement 2 has a perfect meaning and makes sense. This is because the words plate and gaseous have no relation, and the words plate and circular have a relation. That means, relative to plate, the gaseous is not related, and relative to plate, the word circular is related. A statement has a meaning only when there is a relation between the words. So finally, we can state that the meaning of a statement depends on the relation between the words used in it. Let us now learn about the term relative with respect to the positions. There are two typical sets of position. They are right and left, up and down. A real-life example. Click each tab to know more. Right and left. For example, let us consider that two persons A and B are moving opposite to each other. For the person A, the house is on the left side of the road, and for the person B, the house is on the right side of the road. Thus, the position of the house is relative to the observer, that is clearly when speaking of the left and right of a person. Up and down. For example, consider a ball in spherical shape and fix 4 pins on it in all the 4 directions and name them as P, Q or S. In P point of view, the position of pin P appears up and the position of pin Q appears down. But in the view of pin Q, it appears exactly opposite. In the same way, the directions of up and down are not the same for the pins R and S. They change with the position from where the pins are observed. We know that Earth is a sphere, so the upward direction of the vertical position on its surface depends upon the place on the Earth's surface. That is the place where the vertical is drawn. Hence, the notions up and down have no meaning unless the point on the Earth's surface to which they refer is defined. A real-life example. The question, is it day or night, cannot be answered without indicating the point on the globe. Consider 2 points on the Earth's surface A and B, in a way that A is in the day part and B is in the night part. For the same question, the person at A says it is day, and the person at B says it is night. The simple fact is that day and night are relative notions, and the question cannot be answered without indicating the point on the globe where the question is being asked.